Today we solve some problems of the RLC circuits, and this series is going to be the last taught lectures. After this, only those videos would be uploaded as are demanded by the students in explaining something they have not understood or responding to their questions on the email or on the Google Classroom. Other than that, basically after solving these circuits, which are problems I have taken from the past papers. So basically you are having a flavor of what kind of problems had been asked in the past about RLC circuits. So for example, to begin with, this is a problem. I have copied it as is, and let me read it along with you. So let us try to understand it first and then see what we need to do. I think we came across this one earlier on when we realized that this problem cannot be solved using the knowledge of RL and RC circuits alone. So here we need to find the voltage across the switch. So basically when the switch opens, this is a separate circuit and this becomes a separate circuit. So if we take the common thing in both the circuits as a reference, then we need to find the voltage across this resistor and the voltage across this resistor, because in this open is not a loop, because when the switch opens it's an open, but we can take that VST and these two voltages and find what VST is, because knowing this voltage here and this voltage here can help us compute VST. So now if you see, when the switch opens, this circuit is an RL circuit and this circuit is an RLC circuit. So we need our old concepts as well. And this happens in all courses, in all knowledge areas, that whatever you learn earlier on is going to be used somewhere later as well. So it is not that whatever you are learning, questions such that only that particular learning can be employed or used and previous learning is not employed is not possible. So basically the question says find the expression for VST for t greater than 0, that is after it has been opened, the voltage across the switch after it has opened. 5 ut means the voltage was 0, so it was a short. 0 voltage means this voltage, this point and this point were at the same voltage. That is how 0 volt across this is going to be there before t equal to 0 and 5 volts after it. Okay, so even if someone is not familiar about ut and he or she has missed it, the question explained what ut means. So that is how things are. So you are only expected to be tested for your concepts in circuit analysis. So here what we will be doing is ignore that whatever this configuration here is, we have to solve two circuits, this circuit, this circuit. So this is our previous knowledge. So let us try to solve this first. Okay, what do we have here? Let us mark it. So let us say this is V1 and let us say this is V2. So first we need to come up with an expression for this voltage and then an expression for this voltage. So in here, when this circuit, when the switch was closed, this is a DC source, but that came into action after t equal to 0. Initially it was a short. So when the switch was closed, this was shorted. There was no source in the whole circuit. So it means there was no energy in the whole circuit. The circuit was in that state for a long time, from minus infinity to 0 minus. And the capacitor would have no energy, means no voltage on it. And the inductor would have no energy on it, means no current flowing through it. So this voltage would be 0 and this would have no energy in it. So this voltage was 0 before t is equal to 0. So all the energy storing elements in the circuit were with 0 energy state. I hope this is clear. So now when this circuit start operating, when the switch opened, there was no energy in this circuit. So when this opened, and it has no connection with this voltage source, so when this was opened, this came into action as well. So this 5 volt was applied right when this was opening. So it means that this circuit would have no energy in it even after it has opened. So this is very simple. So what is V1t after t is equal to 0? It is 0. So this was easy. So don't be scared when you look at circuits. Okay, things may be very simple. So we have solved for V1. Now the question is, what is V2t? And this is not going to be this simple. Why? Because a source is coming in action in this circuit. So we know that we are going to solve it in a proper way. Now look at this circuit. This is a series RLC circuit. So for a series RLC circuit, what is different that we need to remember for RLC circuits or in comparison to a parallel RLC circuit, and that is the alpha. The alpha here is L over 2R. Remember, for the case of a parallel RLC circuit, alpha is 1 over 2RC, but C is replaced by L. So I think it is R over, sorry. It is R over 2L. So just by remembering what I was trying to say, I intuitively understood or gathered that I have written a wrong equation, because in 1 over 2 RC, that I remembered correctly, C was replaced by L, but R was replaced by 1 by R. I hope you remember that video lecture. So basically this is what we have alpha in a series RLC circuit. Then you should also remember that what is omega 0 or omega naught, that is 1 over under root LC, and whether we need omega d or not is to be found later, to be evaluated later. Why? Because it depends on the values of alpha and omega 0. So here R is 2000 and 2 into 10 millihenry. So we have this thing over here, 2000, 1000 divided by 0.01, which means 10 raised to the power 5. So alpha is 10 raised to the power 5 Nepper per second. What is omega naught? 1 over 0.01 into 5 into 10 raised to the power minus 6 square root. So what do we get here? This would be 0.05 into 10 raised to the power minus 6. Obviously we can employ a calculator, and I don't usually carry a calculator, but let me try to solve this for you. I am very slow with these things. So we are going to get 1 over square root of 50,000. Oh, sorry, it's 10 raised to the power minus 6. I have taken it as 10 raised to the power 6. Again, you see, I am very bad with calculators. It is 10 raised to the power it is 5 into 10 raised to the power minus 8. 5 into 10 raised to the power minus 8. The square root. Now let us apply the square root thing. We get something, and now let us take the reciprocal of it. So we are going to get something like 4472 point something radian per second. So we can see that alpha is definitely, I hope I have not done anything wrong here, alpha is definitely greater than omega naught. So in an RLC circuit, this is the first thing you do. Find alpha, find omega naught, and see their relationship, because their relationship is going to tell whether the circuit is overdamped, underdamped, or critically damped. Now this circuit is overdamped. So if the circuit is overdamped, we know the form of its response. So here we want to find this voltage. So we can use this form. So V2t is equal to the final value of V2, that is V2 at infinity, plus the expression must be of this form, A1 e raised power S1t, we can easily compute S1 and S2, A2 e raised power S2t volts. So what is the V2 at infinity? The voltage across the resistor when a long time has passed. So when a long time has passed and this circuit, capacitor is going to open up. So when this opens up, no current is going to flow and no voltage is going to appear here. So this is 0. So therefore V2t is A1 e raised power. So let us compute S1 and S2 as well. By definition, these are equal to minus alpha plus minus alpha square minus omega naught square. So you can easily compute two real and distinct values here. So I hope you should be able to do this, because it will take me some time to solve for this. But once you have found these values, they will be negative values, minus something t here, minus something t here. So this will be the expression. So all that would be left would be finding A1 and A2. So how you are going to solve here? Now there is a very tricky thing here. So don't get confused. That I need to highlight so that you should not get into problem later on. Finding the voltage across a resistor is not what we learned. Remember, we learned the voltage across a inductor, or the current in a series. The voltage across all the components in parallel, and the current through all the components in series. So we can solve for current, but not for voltage directly. So I am doing this just to tell you a very important thing. So please take very good care and notice of what I am doing here and where will we run into a problem. So while you may think that we can very easily solve for V2t, there is a pitfall coming and we are going to fall into that if we are not careful. So look at this. Suppose these are some values found, that's not important. So how to find A1 and A2? You don't need to cram anything. Just do those simple steps. Put t is equal to 0. So V2 at 0 plus the initial value is equal to e raised power 0 is 1, e raised power 0 is 1. So we get A1 plus A2. We get one equation. So what is V2 at 0 plus? What is the voltage here just after switching? And this is one very important thing. This is not a capacitor or an inductor. So we cannot say the voltage is going to be the same, that V2 0 minus would be equal to V2 0 plus. No, this is not the case here. This is not a capacitor that we can say this. So V2 0 minus can be a different thing. V2 0 plus can be a different thing. In fact, let us try to see what it will be. We clearly know V2 0 minus is 0. There was no energy in the circuit. But what about V2 0 plus? Let us, for this particular instant, t is equal to 0 plus, draw the circuit. So we have a source of 5 volt in action. We have a capacitor with 0 volts across it. 0 volt across, because capacitor voltage before switching is 0, it will remain 0 right after switching. So a 0 volt is represented by a short, not by an open. And how was the inductor behaving before switching? So it had zero current flowing through it, and inductor resists sudden change in current. So what is going to happen? As the switch opens up and this kicks in, zero current will still be flowing in the inductor. And how does the case of zero current be represented? By a symbol, an open. So inductor will be open, capacitor will be short. And what do you think are we going to get the voltage here? This 5 volt is going to appear here. Why? Because in this open loop, KVL must satisfy. So minus 5, 0 here, plus 5, 0 here is equal to 0. I hope you understand. So what is V2 0 plus? It is 5 volts, because based on this knowledge, and it is different. So okay, that's very good. We have one equation. That's not the pitfall I was talking about. The pitfall is coming. So now do this thing. Take the derivative of this equation, that is our solution. Take the derivative of it with respect to t, and then put t is equal to 0. So what do we get? dv2 t by dt is equal to a1 s1 plus a2 s2. This is going to be our second equation if we put t is equal to 0 plus in this derivative. So we know the value of dv2 by dt at t is equal to 0 plus. But how do we know that? We don't know that. And remember, V2 is a voltage across a resistor. For resistance, there is no expression which contains a derivative. So how to find dV by dt for a resistor? For a resistor, we know V is equal to Ri. So in this case, V2 is equal to R, that is 2000. And I, according to the passive sign convention, let us take this I, let us call it I2. So I2 here. So what will be dV2 by dt? That would be 2000 di2 by dt. So you see, we can replace this thing by 2000 derivative of I2. And remember, this derivative of I2 is not only the current that is flowing through the 2 kilo ohm resistor, but also through the inductor as well. So we have come to that current thing again. So that is going to help us resolve it. Now there is an expression that has di by dt in it. We are dealing with inductor current now. Luckily, the resistance current and the inductor current is same. So, and we know VL is equal to L di by dt for a inductor. So luckily here VL is equal to L, value is known, and this is I2. So what is di2 by dt? It is VL over L, the inductor voltage. So what will be di2 by dt at t is equal to 0 will be the inductor voltage at t is equal to 0 over L, which is a constant. So now we want to know what will be VL, at 0 plus, and value of inductance is known. So we have just solved this circuit. So what will be, for example, what will be VC at 0 plus? Is 0 because of capacitor property. What should this be for KVL to be satisfied in here? It is 0, it is 5, it's 5. This must be 0. And it's 0, it's an open. No current is going to flow here. So when no current is going to flow here in this resistor, because the circuit is open, there is no current here, but this voltage is going to appear here as well. I think I have committed a mistake. And although I have committed a mistake, my intuition is basically being violated here. So I had to be cautious here. So I am not removing this video from the course series because I have committed a mistake. Why? I just want you to know that even I can commit mistakes. So this was wrong actually. So how long could I carry on this with this wrong? I could not take long to carry on with this wrong. So here came that point when I was explaining this to you. I suddenly had an idea and I say, oh, I have committed a mistake. How? Because of this thing. I am saying this is open. There is no current flowing here. No current flowing in this. How a voltage is appearing on its terminal. So that was wrong. Actually, this the voltage of this source will appear here. This was 5, this was 0 volt. There is no current flowing here. Sorry for the mistake, but this is a big learning for you. Anybody can commit mistake. That's not important. The issue is how long can he take the mistake along. Sooner or later, the intuition needs to kick in for such simple things. Obviously, this is my fault. This is such a petty thing. We should not make a mistake for this one, but I did. So anybody can commit a mistake. Mistakes are not used to judge people, but their behavior after the mistake is what is important. So basically now you see we have put everything in the right place. This is 5 volts and this is not 5 here, it is a 0. Okay, so it's a 0. Now everything falls in place. It is 0. So although it's not a capacitor, but the voltage across it is 0 because there is no current flowing here. So now this is resolved. We get a 5 here and we get a 0.01 here. So that is something like 500. So the second equation is 500 into 2000 is what is equal to A1, and put values of S1 here and put values of S2 here. So this is the second equation. So solving these two simultaneously, solving 1 and 2 simultaneously will give A1 and A2. And when we know this, we know what is the overall response. So I hope this is clear. It's simple. And let me also tell you a very, very important thing. This is not the only way of doing it. Somebody can come up and say, oh, in series circuit, we used to find the current. So let me find the expression for current. So he or she will start with I2, say I1 or I2, whatever he or she calls this current. So he will say I2 is equal to the final value of I2 at infinity plus A1. Now this value will be different from that A1. This is for I2. It will be different constant. We can call it B1 here, doesn't make a difference. However, this S1 and S2 will still be the same because S1 and S2 depends on alpha and omega naught, and they are not dependent on whether you are taking I2 or V2. Here's for S2T. So if someone's take this and try to start solving, I2, when this opens up, is completely charged, this shorts, basically we are going to get 0 volt here across it, and this opens up, no current is going to flow, this is 0. So expression for I2 would be equal to A1, and S1 and S2 would be the same values for V2. And here, when they take the derivative in finding A1 and A2, di2 by dt is exactly the same thing that we want to find. So you see, even finding I2 and then finding V2, that would be very simple. So finding the expression for I2 and then saying V2 is equal to 2000 times I2 would be getting the same thing, same expression that we are going to find in this case. So that is something that you should understand, that you don't need to cram anything. There is a methodology to solve this. You can commit silly mistakes. Doesn't matter. Even if you have committed this, I would have deducted very few marks, because all this methodology is important. So saying this is zero is not 0, is 5 volt, and writing this here, you are not going to lose much marks. And from the students who apply their minds, I sincerely hope that sooner or later they are going to find, they are going to catch their own mistakes of this form. So basically, this is a very, very important lecture, and in a way, very, very important for you to learn several things. So don't be shy of committing mistakes, but learn to correct them with intuition, with counter reasoning, or something of the sort.